Okay, so now let's look at it. So far, we've done an example that had a single asymptote. We had an example with two asymptotes. Right? So let's look at and if you if you're watching this video, you should have already watched the first two videos. Right? So now that we get to example C here, we're going to look at what happens. I'm going to change. We had that problem before. I'm going to change it just slightly. I'm going to make it into x squared plus 4x plus 3 in this case. Okay? And in the same directions, graph it, including all necessary information. And if you're not sure what the necessary information is, right, then you should go back to the previous videos and just make a checklist for yourself of what we've had, because that should kind of be familiar for you. Okay? So let's factor this, because the first step is always to get the domain restrictions. And to get the domain restrictions, we have to factor that denominator. We factor that denominator, and we see that domain restrictions are at -1 and -3. Okay. We can also see for ourselves, hey, wait a sec, this reduces. Okay, so as soon as you get the domain restrictions for yourself, that's when you actually reduce it. So I'm going to use this problem for the remainder of it, because this and this are practically the same. The only difference is that the domain restrictions change. Right, the domain restriction is different. That reduces out right here for ourselves. Okay, so we want to get the domain restriction before we reduce, and that's a key issue. Right, do domain restrictions before reducing, and use the reduced version for the remainder of the problem. Okay, and that's a key thing, right? You want to make sure, you get that highlighter, you want to highlight that in your notes, because this is a key aspect, right, that people miss as they do it. Okay. That's, I get that question a lot when we're doing this. Right? Okay, let's do the x-intercepts. X-intercepts, let's look here. Right, x-intercepts would be when the y equals 0. It's not possible for the y to equal 0 here. Okay. If you had accidentally done it for this, you would get that -3 was an x-intercept, but it's a domain restriction. It can't be an x-intercept, so it's going to mess you up. That's why we always use this reduced version. So this is the first one. We've seen none for the x-intercepts, and that's okay. It doesn't mean you mess up on anything. Okay. So let's think about the y-intercepts. Y-intercepts, that means you're going to be plugging in. You're going to be plugging in 0 for the x values, and again, let's use the reduced version here, right? So if I plug in 0 for the x values, I get 1. Okay, so we have a y-intercept for ourselves. Great. So we have some information. We have two domain restrictions, and we have a y-intercept. Okay. So let's do our limits now. As x approaches, right? -1 from the left. X approaches -1 from the right. X approaches -3 from the left. X approaches -3 from the right. And the limit as x approaches infinity, and the limit as x approaches -infinity. Okay, make sure to put f of x after each of these. Okay, really careful. You must put that f of x there. Don't you dare tell your AP Calc teacher next year that I said it was okay to leave those blank. I never ever said anything like that, and that is it's kind of like just writing sine without putting an angle after it. Okay, so again, use this version, use this reduced version. Right, like I said, we plug in -1 from the left. That would be like -0.1. No, sorry, -1.1, -1.01, -1.001. Right, the top is always 1 because it's just a number. The denominator is getting closer and closer to 0, but it's a negative number, closer and closer to 0. So it's going to be -infinity, right? -1.1, -1.01, -1.001. These are all negative small numbers. If I'm doing -1 just from the right, the top is 1. It's just this finite number. The right side, right, it would be like negative 0.9, negative 0.99, negative 0.99999. That's going to be a positive small number. That's going to be infinity there. Okay, so we can see, right, what does this tell us? This tells us we have a vertical asymptote at x equals -1. So that's really what we've learned, because it goes up to infinity and down to negative infinity. It tells us where that asymptote is going to be. Okay. Now let's look at -3. Okay. Well, the top is still going to be 1. Right. If I plug in, if I consider this one -3 from the left, that'd be -3.1. Right, which would be like -4.1, and then if I put -3.01 in, it'd be like, oh, I'm sorry. If I plug in let me just do this, -3.1 plus 1 is -2.1, so over 1. Right, if I plug in -3.01 plus 1, that would be -2.01 over 1, and if I plug in, right, -3.001 plus 1 over 1, I get. You can see my denominator is approaching -2, not 0, -2. So that's why this is going to be approaching a limit of -1/2. Okay, so sometimes your domain restrictions aren't going to be infinity or negative infinity, and that's because this denominator here is not approaching something. It's not getting infinitely close to 0. It's getting infinitely close to -2. If I do -3 just to the right, I would be plugging in -2.9, -2.99, and -2.999. You can right, whoops, I forgot to add 1 to that one. Okay, you can see my denominator is getting infinitely close to -2 again. Oh, I'm approaching -2. So what's happening here is my graph is kind of coming together, and that's coming together at the same point. Okay, so what's that going to be? That's going to be a hole or an open circle, and it's going to be at -3, -1/2. It basically just means that we have a domain restriction. Our graph is coming together, right? They're trending together, and they're going to hit at the same point, but it's going to be an open circle there, okay, or a hole. Okay, so domain restrictions, they fit into these two classifications, either a vertical asymptote or a hole. Right, their vertical asymptote is they're approaching infinity or negative infinity. They're a hole or an open circle if you're approaching a finite value. Okay. Okay, so if we approach infinity, again, let's look at this guy here. Well, our top is 1. The bottom is infinity plus 1, which is basically infinity. 1 divided by infinity, hey, that's practically 0. And it's going to be 1 over negative infinity, practically 0. Okay, so we can see for ourselves that we have a horizontal asymptote at y equals 0. So we have these key pieces of information. So far we found domain restrictions, x-intercepts, y-intercepts, vertical asymptote, hole, open circle, and a horizontal asymptote. So we've got a whole bunch of information for our graph. Right. Let's think if we cross that horizontal asymptote. Okay, so that would be if 1 over x plus 1 equaled the horizontal asymptote, which is 0, and we can see that's never going to happen, because, right, so the answer there would be no. Right? No. So if we looked at our graph, we'd have our y-intercept, we'd have our vertical asymptote, okay, we'd have our open circle at we'd have our horizontal asymptote. Okay. With this vertical asymptote, we can see as we're approaching -1 from the left, it's going to be going down. So as we're approaching -1 from the right, it's going to be going up. Okay, and then we need to approach our horizontal asymptotes, and it does not cross for ourselves right there. Okay, so our graph would look kind of like that when it's all said and done.